Okay, so, oh no, what's going on? Oh my God, I need a doctor, please. Is there a doctor in the room? Doctor, please.
Did anyone say doctor?
Yes, please, I need a doctor. Thank you, it's a doctor here.
How's it going?
It's terrible. I'm building
please,
this system.
Step into my office, please.
Sorry, yeah. Thank you for coming.
Just come down. Everything's okay.
Okay. No, because I'm building this system, it's a terrible. I'm working all the time doing TDD all the time, but crashes and crashes. So TDD doesn't work, man. I don't know.
How's that possible? You said you build a system, do it.
Of course. I write all the code. I write all the code of the system. Then I write the test.
What? Wait.
What?
You meant you first write the test,
No.
then you write the code?
No. I'm doing TDD, man. That means that I write the code and then I write the test. Sometimes I write 20 tests and try to make them pass.
How are you going to write 20 tests?
I'm doing TDD. It's not that.
No.
What?
I guess I have some bad news for you.
Really?
Just
do I have
take
to take
it
a
easy.
pill?
But I think you're not doing TDD. Okay?
Really? So somebody lied to me.
Maybe. Many books lie about this. All right. So
what should I do?
Calm
Do
down.
you have a prescription or
Yes,
something?
of course. First, remember what doing TDD means, right?
Okay. What's that?
We write a single failing test, we make it pass,
Oh, okay.
and then we refactor, and then we just repeat that cycle over and over again.
Oh, okay. So it's that easy.
It is easy, but you're gonna need some medication, and I have some experimental medication for you today.
Oh, cool. Thank you. So but is it safe or?
It might hurt a little bit, but I mean, you're a big guy.
Okay. Old, not big.
Okay, so I'm going to prescribe you this application.
Okay.
All right?
Thank you. Dr.
think
TDD application.
Dr. TDD.
Thank you. Thank you very
I
much.
guess it will help you in your way to learn TDD properly.
Okay.
Hopefully,
I'll see you in a month.
Totally.
Okay.
Yeah.
Thank you. Now with you, Dr. TDD.
All right, welcome. So red-green-refactor, or the TDD cycle. If you ask me, for me, this is beautiful. Just 3 simple steps are enough to describe the whole technique. But yet, it is very difficult to learn properly because it requires a strong cultural change in the way we develop and in the way we understand what software development is. Okay? Good news is, once we get it right, we can grow systems. I like the grow definition versus the build one in an iterative and an incremental way, one test at a time, and of course, with immediate feedback. And for me, that part is key. We all agree that development is a learning activity. And of course, in every learning activity, feedback is key. And if you ask me, it's directly related to the quality of the knowledge we're getting in that activity. We want to have, in our case, rapid feedback or immediate feedback, because that's what allows the incremental and iterative way of developing software. Okay, we've been talking about immediate response and the importance of that for a long time, and TDD allows that when done properly. And speaking of learning and immediate feedback, a long time ago I started thinking about how do we learn TDD, or at least how did I? I remember in the early days I used to just read material, try to work it on my own. Later on I have some courses at the university. We were a bunch of students, probably 50 at that time. And the way we practiced TDD and learn was, we were assigned some problem to work on. We worked solving that problem, hopefully doing TDD. And by the end of the class, we checked and we discussed how our experience was, and if there was something wrong, if someone maybe did not do TDD, well, that was the moment when we found out. But if you think about the TDD spirit, which is rapid feedback, we were learning TDD in a non-TDD way, right? Because we did not have rapid feedback about how we were learning TDD. And that got me thinking, how is that possible, right? For me, it sounded like a contradiction. We're learning TDD in a non-TDD way, right? And that was the spark that got me thinking if there is something we can do about it, and that's what we're going to talk about today. So Dr. TDD tries to solve that problem, and we're going to see in a few seconds what is it about. But first, I'm going to give you the introduction that I give to my family when they ask me, what are you going to do in Neuquén dressed like that? Okay? So everyone remembers Word 97, probably. This little guy here was Clippy. He was Microsoft Word's assistant. From time to time, it came out and said, hey, it looks like you're trying to write a letter. Do you want me to apply this template for you? Okay, Dr. TDD is just like that, but instead of Word, of course, we have Smalltalk. In this case, it's Faro. And instead of documents, we have the system browser, which is where we spend most of the time. And of course, if Clippy was the Microsoft Word expert, we need something to replace Clippy. We need an expert TDD assistant. So, yeah, we came out with Hernan Wilkinson. We renamed it Will Clippy. And from now on, it's just as simple as we zip this guy and we convert it in a Nautilus plugin. And that's it. Okay? So this is Dr. TDD. It's a real-time assistant for helping you learn TDD better and correct the possible errors you can make while learning it. It's very simple. We didn't, because this is a tool to assess learning, we didn't want anything that distracts you. We didn't want a separate window or something that was floating over the browser. It's just that toolbar. We have the thermometer that measures, of course, the fever. When it's low, you're doing TDD correctly. When the fever goes all the way up, that means you're not doing TDD. Then we have the package. In that example is Dr. TDD, and we have the diagnostic for that package. In this case, is all the tests are passing. Then we have, because it's a doctor, we have the recommendation. In this case, to continue doing TDD correctly, what you have to do is to write a failing test. And most of the time, we discover through experience that those recommendations can be applied automatically, so the student doesn't have the friction of, okay, I have to create a new class and a new test. So most of the time, that button will be enabled, apply recommendation, and we just do that for you. Okay, so we're going to see it in action now. So once you open the browser, we see the Dr. TDD plugin. I'm going to start it here in this package. And as we just saw, the project is empty, so all tests are passing, and the recommendation is to write the failing one. Again, if I were to write the first test, I have to think of how am I going to name the test class and create it, and the same goes for the test. If we just click Apply Recommendation, Dr. TDD will do that for you, and we are ready to go right here. So for the sake of showing you Dr. TDD, let's implement a simple stack. Notice that now that we created the first test, the fever went a little bit up. That doesn't mean we're not doing TDD. Remember, not doing TDD is the fever all the way up. What this means is, okay, you're on your way to do step 1, which is write the failing test. You just wrote a new one. We don't know if it's failing or not yet. So what the fever tells you is, okay, watch out, because there's only one thing you can do to keep doing TDD correctly, and that is run the test and confirm that it is failing, right? Anything you do outside that will technically take you out the TDD cycle, and you won't be doing TDD. The tool is not that strict. We're going to see that in a second, but that's the spirit. Okay, run the test is a recommendation. I can do it clicking that button. Is empty, does not exist. We're going to create it, and we're going to do step 2, which is the simplest thing you can do to make the test pass. Okay, the test passed. Now we're back on the green step. All the tests are passing, and again, the recommendation is to write a failing test, and the fever went all the way down. Let's create a new test, and what will happen if I try to break out the TDD cycle now? Let's suppose that I say, okay, I want to write 2 tests at once, not 1. Notice that the fever went even higher, so this means that we are 1 step from not doing TDD, but we give you the chance to undo your mistake and go back to the TDD cycle. Not always we can allow you to do that. In this case, the recommendation is, okay, you wrote 2 methods or more than 1, you just have to keep 1. So if you apply the recommendation, you get to choose which method, which test you want to keep, and the other ones we're going to delete them. Notice that we're back on the state that we were in the previous example. New test written, everything is okay. And now we have to run this test, write this test, and run it to make it fail. All right? So we're going to push something into the stack to get that failing test. All right. We're going to apply the recommendation, run the test. Of course, push does not exist. And for now, we're going to do the simplest thing I can think of right now, which is use the element push as a marker to say, hey, this tag is empty or not. Of course, the assertion failed. That's because we implemented is empty returning true. We're going to implement it, checking for nil on the contents instance variable. Notice that the fever is all the way down. The diagnostic is the failing test passed. And now the recommendation is run all the tests. Remember that to go back to the green state, we have to run all the tests, not just the one which just made pass, right? So if you apply recommendation, Dr. TDD will do that for you. We are not seeing this in this example, but if you have more than one test suite, then running all the tests for going back to green means running the failing test you just fixed, running all the tests in the same test suite, and then running all the tests in all the package you're working on. In this case, it's Dr. TDD Sandbox. Okay? If you click Apply Recommendation, we do that for you automatically. All right. So let's write more than one test, and let's try to go to not doing TDD. So just don't do this at home. Okay? New test written, everything's okay. We write a new one. Nothing new, we saw this example before. But what if I say, you know what, I don't care, I really want to write two tests at once. This is the scenario I talked to you before. This is not doing TDD. Once you reach this point, there's no going back. The only thing you can do to go back to the TDD cycle is to just do everything you have to do to make all the tests pass. We try very hard to avoid the students going into this state. That's why we support undoing the mistakes. But once you do we try to track 2 mistakes at most. Once you do that, then there's no going back, and all the feedback we can give to you is to just make the test pass, and that's it. So in this case, we're gonna make this pass, and everyone's happy again. Okay, another things that can take you out of the TDD cycle, of course, we are developers and we know what we are doing, and one might be tempted to say, okay, I know where this implementation is going, probably I will end up saving or storing all the elements of my stack in a collection, so why not just do that? So Dr. TDD says, okay, you wrote a model method before test, or you modified a model method before writing that test. The recommendation technically is you have to remove it, because you have to have a test that made you write that new method or modify the method you were working on. Of course, if I click apply recommendation, the initialize method I just wrote will be deleted. But we know what we're doing, so we just run the test just in case, and we found out that we broke the implementation. So again, because we didn't follow the recommendation and we didn't undo the mistake, now we're back in not doing TDD again, and we have to make all the tests pass. If we click apply recommendation, we debug the first failing test for you, so you don't have to do that again. They go either from the design of the UI or the flow that Dr. TDD imposes to the student, is to reduce friction, so you don't have to find the failing test, we do it for you. And now we're just ready to fix our stack. We're going to check if contents is empty here. Oops, I do this all the time. Okay, the next failing test, of course, is this is an integer, right? This is what we were doing here. We're going to fix it, sending the add message here. And we're back to green again. Just as I saw you, there's a bunch of scenarios that can lead you to not doing TDD. It's very interesting to try to come up with a solution, or at least to say, okay, what should you do here, right? Or in which ways we can allow the student to undo the mistakes so they don't end up in not doing TDD. Okay. So another interesting thing about Dr. TDD is we are small talkers, so I said I have to develop Dr. TDD using Dr. TDD, right? But the problem is that it doesn't exist yet. So what do I do, right? So the first thing I did was to implement the TDD cycle 3 tests. So Dr. TDD could detect if I was following the TDD cycle correctly. And from that moment on, I just hacked an UI to give me feedback, and I used Dr. TDD to develop Dr. TDD. And the fun part was that when one test failed, the UI crashes and Dr. TDD crashes, and it was a mess. But what I want to show you that I discovered that was a very fun experience is how to do that. So this is version 1. It doesn't matter what I'm doing here, but this was the Dr. TDD UI. Basically, I was just writing to the transcript. Should I switch to that one? One test failed. I was writing to the transcript, very simple UI, but this allowed me to develop Dr. TDD using Dr. TDD. I have each line here is a feedback that I was getting. In this case, is probably you can read it, but it's write a failing test, refactor your code, or write a failing test. This was a test fail recommendation, test fail event, sorry. And once I started working with Dr. TDD, I discovered, okay, I need more feedback. I need more information about which test fail or the mistake I made. So version 2 was something like this. Now I could select the package I wanted to work on, and the UI was a little bit more complex. We have like what happened, the problems that I had, the reasons because I had those problems. This was the test that was failing, and we have some more information here. But again, as I started using it, I felt that there was too much friction between switching windows, between the browser I was working on and this window that was like floating around. And that wasn't a nice user experience. And of course, if someone is already struggling to learn TDD, that wasn't helping. Okay? And let me give you a quick example of what it means to have more feedback about what I'm doing. I just wrote a new test, just as I did before. And now let's imagine that I modify this test, right? While I already wrote a new one. What do you think it will happen here? Or what should happen? If you think about it in terms of the TDD step, we are modifying a new test is basically writing a new one because we don't no longer know if it's failing or not. Okay? So now technically we have two new tests instead of one. The first one we wrote and the second one we just modified, right? And this happens very frequently, and you can modify not only once but many tests and do it several times, 3, 4, whatever. So when I was talking before that the UI didn't give me enough feedback, this is what some of the things I was talking about. If I click on more information, here I get this nice browser that tells me, okay, this method used to be written like this. The current version is this one. To go back to TDD, or to go back to the test we knew that was passing, you have to revert all the changes. Of course, I'm showing just one method here. You can have many. If you click on revert all methods, that's exactly what we do. We go back to one. And if you notice, we went back to new test written again, and we are on track again. All right. Some fun things that also happen while developing Dr. TDD. As you can imagine, there's a lot of test cases, right? Basically, we have a really big state machine with lots of transitions. Each state has probably 5 or 6 transitions. We have probably between, I don't remember, 15 or 20 states, but you can imagine it is a big system. So writing the first test was easy. As I kept writing tests, I needed a way to say, okay, where are all the tests that talk about starting from a green state? I just use the browser, try to find those tests. But as I kept adding tests, we have probably 500 right now, that wasn't a hard task. I tried for a moment to keep it on an Excel file, just as every good system starts, but it didn't go very well. So I said, I need to have this information in Smalltalk, right? I tried for a second to have Excel in Smalltalk, but that wasn't a good idea. And then I took a quick detour. I said, okay, I need to stop developing Dr TDD and think about this for a second. And I realized, okay, I have a style of writing tests that I use. For this particular project, I decided to use given then when. I'm not a fan, but for this worked kind of nice. And this allowed me to describe, okay, given we're starting from a green state, when a new test is written, then this is what happened, right? The state is new test written, and the doctor recommends running the new test. That is just what the test does. So I said, okay, so kind of I have the information there, right? So what I did was I reified the test selector, in this case, the given then when selector, so I could manipulate that information that I already have in my system. And once I did that, of course, I did a browser to access that information easily. And this is the given then when browser. It's just like another browser. This is all the tests sorted by the given. We have the when, we have the then. And if we want to see which test talks about starting from a green state, I can write here. I don't know if you can read, but I wrote TDD is green, and have all my test cases that it starts from the green step, and then I get all the transitions and all the ending states, right? So this worked like a charm. I have all the information available for me, but as I kept adding more and more tests, just reading text wasn't enough, right? So I started to, for thinking about the test cases and the system I was building, I need to see it. So I said, all right, I already have all the information here, so let's hack something. So what I did is, basically we have a state machine, so we have a graph, so we can draw that graph, and these are all the states of Dr. TDD according to the test I wrote, okay? As you can see, it's a really, really big system. Of course, you usually don't see the system as a whole. You usually want to see a subset of that graph. So later I implemented this scenario search when I say, okay, given I want to start from the green state and I'm going to end up in the red state, which are the transitions that gets me there? And I just reflect on my model, and I can get that information. I can see that information, and if I just hover here, I see which transition leads me to this state. Okay. So this was a big moment for me, and I'm very glad I took this detour, because many times we hear that, okay, tests are the runnable specification, and we also say tests are like a live documentation, and I totally agree with that. But I think that if we can extract the information we have about the system from your test, then it's not really live documentation, right? It's too hard to understand. Of course, it's still a live specification, but it's not live documentation, at least to me. So what I would like for you to think is like, how are you writing your test, and how, if you can, are extracting information from your test to make the most of it. So that's it. Thank you. I don't know if we have time for questions. All right. I don't know if there's any, but yeah.
Hello, hello. Question?
A question is, what's the logic behind this rule that prevents you from writing 2 tests instead of just one, then the code, etc.?
Well, there's a lot of things that can go wrong if you write 2 tests. First, which is kind of non-technical, is you're kind of showing anxiety. So you have to, I believe that you have to take that down if you want to develop a system in a natural way and incremental way. Of course, if you write 2 tests, you're thinking too much. At the same time, probably you, with the first, if you try to make the first test pass, by the time you do that, probably the second test either already passed, so you generalize too much for making the first test pass, or it might be that the second test no longer makes sense, right? That's more obvious if you write more than 2 tests, of course, at once. Yeah. And it's not very incremental, right, if you try to do too much at once.
So now the next is rather a comment, because I think the emphasis on test, unit test, is very good. It's okay to bring that to bring attention on them and this methodology, but I think that your TDD doctor could benefit from adding another concept which is very close to the test, which is the validation concept. So there is a semantic difference between a validation and a test.
Yes.
You can think of a test as an example, as exposing an example, and a validation as exposing an axiom or a rule.
A formal proof, you can say.
Yeah, okay, yes. So, so when you propose or check that the programmer is following the methodology, instead of testing that, you should, I think, be validating that. And the validations, or the validator objects, will capture that knowledge in a way that is closer to your intention, I think.
Okay. So you're talking about doing the same thing, but from the validation side more than...
Yes, my proposal is just to introduce the notion of validation in a formal way. It's very similar to tests. And then use it, once you have it, you start using it, for instance, for your system, for this TDD doctor. So you will very quickly find that some checks go better with the validation and some other with the tests. And this will enhance the feedback and also the structure of and the help provided by the tool.
Cool, I like it. Yeah, let's talk later about that. Thank you.
Okay, thank you.